In this video, we will try to investigate the connection between average and probability, to understand what the concept of average actually tells us. If you Google the definition of average, you'll find something like this: a number expressing the central value in a set of data. The question arises, how it expresses the data, and what does it mean by central or typical value? We will try to figure it out in today's lecture. We need to know when should we calculate average, or the arithmetic mean. We calculate it only when the data is approximately normally distributed. It means, in our nature, there are data that shapes like a bell when we plot them in a graph papers. Such data includes exam scores, heights, program runtime, cries per week, screen times, etc. And we do not calculate the arithmetic mean when the data is not normally distributed. For such type of data, we use other types of Pythagorean means, like geometric mean for growth rate data and harmonic mean for fluctuated data. Here's an example for you. The following univariate dataset represents the exam scores of 37 students. If you create a histogram and draw a curve above the histogram, you'll notice that that curve is creating a bell-shaped figure. In case you forget how to draw a histogram, here's a couple of snaps to remind you the method. If you use an statistical software, for example, I used Python, it will accurately draw the histogram for you. Now, look that the curve above the histogram is really bell-shaped. The average score, which is represented by mu, is 10.42 and the population standard deviation is 2.73. However, the data is not entirely normally distributed. It is a bit left skewed. We can say that the data is approximately normally distributed. Now let's get back to the perfect normally distributed data. This is the histogram of a normally distributed data. There are some properties of it which can be described by the empirical rule. But before we delve deeper into that, let me tell one more thing. In a normally distributed data, the mean's position is at the midpoint of the x-axis. This midpoint, or the mean, divides the area under curve into two portions. The entire area under the curve denotes the maximum probability value, which is 1. In that sense, if you randomly pick a value from a normally distributed data, there is 50% chance that the value is greater than the mean, and 50% chance that the value is smaller than the mean. According to the rule, approximately 68% of the data points falls within one standard deviation of the mean, 95% is from 2 standard deviation of the mean, and 99.7% is from 3 standard deviation of the mean. For example, assume that x is a random variable which is normally distributed with a mean and standard deviation of 62.34 and 5.03. The size of x is 100. It means there are total 100 data points. To understand clearly, you can assume that x stands for exam scores and data points stands for the marks earned by the students. Now, according to the rule, 68 students got the marks within this interval 62.34 to 5.03 and 62.34 plus 5.03. The following interpretations are similar to this. It denotes that, in a normally distributed data, 68% the data points are closest to the mean. I marked the area read, where this 68% of the data lies in. 95% and 99.7% data lies in the orange and green area respectively. If you want, then you can verify the empirical rule too. Since I am not a mathematician, so I will use programming approach for the verification. First of all, we will write a program to create a normally distributed data. Then we will count the data points with its corresponding threshold of standard deviation. After running the program, we get this result. We can verify the rule on our real-life dataset too, the quiz data that we chose earlier. The result is shown here. So now, we can conclude the following points. Average is a measure of central tendency since we usually calculate this only when the data is normally distributed. And normally distributed dataset has properties that can be explained by the empirical rule. Empirical rule, on the other hand, can describe the connection between average and probability. If a random data point is arbitrarily chosen from a box of every data, there is 68% probability that the chosen number will be closest to the number that divides the dataset into two equal parts, and this divider number is considered as the arithmetic mean, or average. Since 68% is quite significant to represent maximum and there can exist no outlier within this threshold, we can state that average is the number that best represents the dataset by denoting the central tendency of the data points of the respective set.